These days, when people discuss AI, they typically are talking about something like Gemini or Midjourney, or Manus, Claude, Sora, or DALL. But what exactly do we mean by artificial intelligence here? First things first, here in the 21st century, AI isn't a blonde little robot that thinks and feels the way a human does. It's not hardware, but rather software. Essentially, clever computer programs that can accomplish very specific tasks really, really well by copying human-like patterns. Consider how Gemini knows how to respond to the questions you ask it, or how Midjourney generates beautiful images purely from the text you type. They're amazing, but they're not really thinking in the way we are. Today's AI systems are very good at pattern recognition, which is why you can unlock an iPhone with your face or use Google Photos to search through old pictures of your cats. Gemini, for example, reads billions of sentences from books, web pages, and conversations, learning how words typically combine with one another. So when you say something to Gemini, it doesn't actually understand what you're asking, but instead predicts the most likely words to follow based on what it has learned. Think of AI as a supersonic librarian who can never read but instantaneously locate the perfect answer in a vast library, not as a human who can truly understand how you feel or what you mean. Plus, contemporary AI is not only text-based or chatbot-based. Enter tools like Midjourney and DALL-E that take basic text input commands, something like a cat in a spacesuit on Mars, and transform the words into complex, believable images. But how? Well, they've looked at millions of other images that we created, learning about concepts such as cats, spacesuits, and Mars. By combining these words, the AI predicts what this new picture should look like, based on past examples. It's not voodoo, it's sophisticated pattern recognition at play. Now, AI tools like Manus.im and Claude, while assisting with content generation or crisp summarization, they function the same way in they learn from content which is available. Imagine AI watching thousands of experts writing at work and taking careful notes of how they structure sentences and explain ideas. Later, when you prompt the AI to write something novel, it finds memories of the examples it learned, predicting and orchestrating sentences with the information it already has. But there is an essential difference to keep in mind. AI doesn't really get context or common sense the way humans do. It's not going to feel sad or excited or frustrated, really. It might generate plausible-sounding sentences or even images that look like art. But it is only running patterns, devoid of any spark of genuine thought or feeling. Have you ever thought how an AI can now accurately generate text in response, or how wonderful images can be recreated? The answer is surprisingly simple. It learns from massive amounts of data. But what does that really mean? Consider how people learn for a start. If you have seen hundreds of dogs in your time, you will recognize one easily even if it's a breed you've never seen before. Your brain knows the smell of 4 legs, fur, tail, barking. AI does something similar, though in a more stripped-down form. It doesn't have your experience or feelings. It processes vast numbers of examples to acquire patterns. Consider the example of Gemini, one of the buzzier AI tools. Gemini, which reads through billions of sentences from websites, books, articles, and social media. As it scans this huge mass of text, it starts to notice common patterns. It figures out how words generally fit together, the way you can predict the end of a familiar sentence. The more data Gemini can ingest, the better it is at predicting the next word, giving it the sensation of understanding your questions or conversations, even though it is, in the end, just looking for patterns. Likewise, AI tools such as Midjourney or DALL-E, which create images from text prompts, have been taught by studying the millions of pictures that are labeled with descriptions. For instance, such AI models go through millions of images of cats, mountains, or spaceships until they learn the visual patterns that correspond to these words. Eventually, when you request something similar, like a cat sitting on top of a spaceship, the AI goes back and recombines the patterns it already knows to create something new. But AI doesn't have an inherent understanding of what is correct or useful. People need to train it for that. Human programmers meticulously choose the seed data, so the AI is learning healthy, useful, and relevant patterns. For example, a computer program based on AI is trained on texts that have been vetted by humans to ensure it steers clear of biased or inappropriate answers. It's the equivalent of teaching someone to ride a bike with training wheels. Eventually, the AI gets good enough to ride on its own, but only within evident constraints. It's also worth remembering the more data AI sees, the better it gets. That's why Silicon Valley AI companies constantly feed their systems new examples, new sentences or fresh images or additional video footage. Each new source of that information helps AI get better at observing patterns, which makes its responses more accurate and more helpful. You may hear words like neural networks or transformers thrown around when people talk about AI. So that sounds complicated, but in fact, if we break it down, it's simple. It is inspired by our brains, the neural network. Some neurons are sensitive to touch and can tell if you are holding an object without even looking at it. They connect to one another, and each connection helps you think, learn, and make decisions. All neural networks attempt to mimic this concept, albeit in a simplified digital version. Neural networks, rather than biological cells, have nodes. Each node computes trivial inputs and transmits it to other nodes, thus inducing a chain reaction. With thousands or even millions of such nodes working together, AI can perform astonishingly complex tasks. Let's look at a simple case. Picture yourself in the role of training an AI to recognize cats. At the first layer of nodes, it may notice very simple features like lines, colors, or shapes. The next layer could recognize that the shapes make ears or eyes. Deeper layers begin to discern combinations. Ears plus eyes plus whiskers. And after many layers, the AI can unambiguously recognize this picture has a cat in it. Each layer of nodes makes a little more sense of the data. And the final layer produces the output of the algorithm, much in the same way that your brain makes sense of, say, the letters on this page. You can more or less think of the output as an educated guess. So then, what about those transformers? Transformers are a type of neural network that have transformed the way AI processes language and generates images. Previous neural networks followed one word with the next, processing information in a step-by-step way, which was slow and inefficient. Transformers, on the other hand, consider all words or image elements at once and focus on understanding how each part relates to all the others. Think of reading a sentence and knowing what every word means at once. Rather than reading each word one at a time, this is something that AI is already much better at understanding: context and meaning. For instance, Gemini leverages transformers to comprehend the questions you ask and respond in a prompt and accurate way, making the response sound more human. When you ask a question, Gemini doesn't simply read words. It immediately grasps the relationship between your words for a smarter and more pertinent response. Likewise, concepts like Midjourney employ transformers to get a grasp of the relationship between your text and the imagery they've been trained on to produce creative visuals that meet your request. But remember, no matter how cutting-edge neural networks and transformers are not really understanding, feeling, or thinking like humans. They're essentially just clever devices for recognizing patterns extremely well and quickly. First, a point of terminology: chatbots don't actually understand conversations, how we do. Instead, they have simply become very good at figuring out what you want to hear next. Close your eyes and imagine you're talking to a friend, and halfway through the following sentence, you know exactly what your friend will be saying. You achieve this by taking into account the context, their tone, and previous conversations. Gemini does something similar, but thanks to pattern recognition, not comprehension per se. Gemini learns to read by digesting billions of words written by people all over the internet. This education comes from books, websites, social media conversations, and any number of other places. As it reads through all that text, Gemini starts to learn about patterns, including, say, which words tend to follow others or precede them. For instance, if you type "good morning," "how are," Gemini will already predict the most likely next word is "you," because it has looked at that phrase a million times. But it goes even deeper. Contemporary chatbots are not just predicting individual words, but predicting whole sentences and discourse context. And thanks to a special neural network of theirs called transformers, which we talked about earlier, they can once process the whole sentence you write, making brief work of how each word connects to the next. If you say, for example, "tell me an interesting dolphin fact," Gemini doesn't simply stare at each one of those words. It mentally combines interesting, dolphin, and fact, understanding what sort of answer you're looking for. It then sifts through its large pattern database to craft the best and most believable response. Another trick chatbots use is what's known as fine-tuning, a nice way of saying more training by real humans. After Gemini's original training, thousands of AI responses are vetted by humans who steer Gemini toward better ones. Think instead of a teacher gently nudging a student's answers into correctness. Human beings perform the same task telling Gemini, hey, this response is great, but you should work on this one. The more you do this, the better Gemini gets. And I must say, it sounds extremely human-like. Yet for all the sense it makes, chatbots don't actually think or feel. If they ask Gemini whether it is happy or sad, it can give an answer that sounds roughly cogent, because it has been trained to spot patterns in human discussions of emotions. But in fact, Gemini itself feels no emotion. Rather, it produces a response to its question based on the most likely pattern it has learned when considering its data. Here's a quick jaunt into how humans project something. Now let's say you're asked, visualize a flying blue elephant for me. Even though you've undoubtedly never glimpsed an elephant in flight, your brain instantly paints a mental picture of the creature because you've seen elephants, you've seen the color blue, and you're up to speed on the concept of flying. You thread these disparate thoughts together in your mind and end up creating a new picture. AI does something comparable, but with data, not imagination. To generate images, these AI systems are trained on vast databases containing millions of pictures along with descriptions. For instance, they have seen countless pictures of objects whose labels are respectively elephant, blue, flying things, such as birds and bugs. You type in a blue elephant flying, and the AI connects patterns it has learned from those separate images, but put those patterns together in a way that is logical and visually plausible. But there is another important factor: diffusion. It gets complicated quickly, but let's break it down. Diffusion is essentially AI's process for incrementally filling out an image. Picture beginning with a fuzzy, random cloud of dots. Gradually, the AI uses such data to adjust and sharpen this cloud, step by step to align with your description, like focusing a blurry camera lens over time. Little by little, each small tweak refines the image until the AI finally spits out a clean, detailed visual. Video production with AI tools like Sora operates similarly, but involves one more step. Rather than producing one image at a time, we produce many consecutive, similar ones to create smooth, realistic motion. It is similar to an old flipbook animation, where a rapid succession of similar pictures displayed one after another creates the illusion of movement. The AI leverages what it learned from the many video clips it was shown during the training to be sure that one motion looks natural and is consistent with the others. But remember, AI-generated images aren't always perfect on the first go-around. They are trained on general patterns, so sometimes you get tiny errors. Fingers looking a little weird, backgrounds getting funky. These occur for the simple reason that AI does not really know what objects are. It can only recognize patterns. But over time, as AI systems get better and are trained on more and better quality images, these imperfections should diminish. Modern AI is impressive. It can converse naturally and create images, produce video, and more recently, summarized vast blocks of text into coherent chunks. But it's crucial to understand its limitations and dispel some common misconceptions. The biggest misunderstanding is that AI knows or reasons the way human beings do. It doesn't. AI tools like Gemini or Midjourney function entirely through pattern recognition. They are great at predicting what comes next, be it the next word in a sentence or the next detail in an image, but have no real understanding. For instance, an AI can write a moving story about sadness, but it's not feeling sad. It's just organizing words into a pattern it has learned from millions of human-authored stories. Another misconception is that AI makes everything perfect, that AI can always come up with optimal outputs or solutions. In fact, AI gets it wrong a lot of the time. Sure, sometimes Gemini will give the wrong answer, and a Midjourney may put out a funny-looking middle image. This occurs due to the fact that AI simply replicates learned patterns. If it has learned from some incorrect or unusual pattern in its training set, it may reproduce these patterns later. Think of AI as a student who studied a Google of textbooks, and if there are errors in some textbooks, the student is just as likely to make those errors. AI also struggles with common sense. As humans, we naturally comprehend such similar contexts. For example, it's intuitive to us that ice cream loses its form when placed in a hot environment. AI, though, doesn't, as a matter of course, register such obvious truths unless it is explicitly taught. Ask an AI a weird or tricky question that depends on common sense, and maybe you'll get an answer that makes you scratch your head. That's because AI doesn't really know facts at all. It's just playing back what seems most likely, given what it learned from its training data. Also, AI depends on the quality and nature of the data on which it has been trained. If the data used to train the AI system is not diverse or contains biases, the AI may be biased or be limited in some way. For instance, if AI were to be trained on pictures of cats from one particular breed, it might have trouble recognizing cats that look very different from that breed. The AI doesn't know it's biased. It merely manifests the data it has been trained on. And then there's the fear of total human unemployment due to AI. AI does indeed change jobs, but usually it supplements human skills rather than replacing them outright. AI tools make humans work faster, make fewer errors, and more creatively by freeing humans from the grunt work of, say, sending emails, summarizing data, or coming up with the first stab at a design idea. That machines can already do. Here's what AI is, and more importantly, what it's not. It might seem like magic, but behind the scenes, it's all pattern, data, and smart design.